Complex numbers. Well, complex numbers consist of real part, as this real person here, and imaginary part, as this imaginary figure here. But let's take a closer look at the imaginary part. Let's say we have a quadratic equation, x squared plus 1. Okay, let's send the 1 to the other side. It will be x squared equal negative 1. But as you see here, x squared can't give us a negative value because the square will remove the negative. So this can't be real. But let's continue. Let's take the square root of both sides, x squared and negative 1, to remove the square from the x. So we have x squared equal positive or negative square root of negative 1. Positive or negative is inserted before the square root to indicate that it may have a positive or a negative value. Okay, we haven't seen the square root of negative 1 before, so we will call it I. So x will be positive or negative I. But what is I? I is the square root of negative 1. Okay, let's take a closer look at I. If we take I squared, it will be negative 1. And I cubed, it will be I squared multiplied by I, or I power 2 plus 1. And it will give us negative 1, as I squared is negative 1, multiplied by I. So I cubed is negative I. And I power 4 can divide it into I power 2 and I power 2. So it's negative 1 multiplied by negative 1. So I power 4 will always be 1. Okay. If we have I power 5, it will be I power 4 I. We already know that I power 4 is 1. So I power 5 will be 1 I. So I power 5 is equal to I. General. Let's see here. If we have I power 4n, what is in any number? If we have 4 multiplied by any number, let's say 4, 8, 16, any number, 40, 400, 4000. Okay, any number can be divided by 4. Power is power to the I, it will give us 1. Let's take an example, I power 40. We can make it I power 4 all power 10. So it will give us I power 4 is always equal to 1, and 1 power 10 will always be equal to 1. Okay? Okay. If we have I power 4 plus 1, it will always give us I. As previous, let's see an example. I power 41. It will be I power 4 times 10 multiplied by I. Or I power 40. All power to 10 plus 1. So it will be I power 4 is always equal to 1. All of this part will be equal to 1. So we have 1 I. So I power 41 will be equal to I. Okay, let's continue. I power 4n plus 2 will be negative 1. X I power 30 is I power 4 all power 7 multiplied by I power 2. Then it will give us 1 and negative 1, in which will give us negative 1. Okay, if we have I power 4n plus 3, it will give us negative I. As an example, I power negative 61. It will be equal to I power 4 multiplied by negative 16, or multiplied by I power 3. Okay, every I power 4 will be 1, so 1 power anything will give us 1 also, and I power 3, we already know it, give us a negative I. So it will be negative I. Okay, so let's remember, I power 2 will be negative 1, and I power 3 will be negative I, and I power 4 is 1, And finally, I power 5 is positive I. And this is the general formula for higher powers. I power 4n equal 1, I power 4n plus 1 equal I power 4n plus 2 equal negative 1, I power 4n plus 3 will be equal to negative I. Exercise 1. We have I power 2020. We will divide 2020 over 4. Take 2020 over 4. It have a real number here, 505, and it's an integer, not a fraction. So it's 4n. Okay, it's I power 4n here. It's I power 4 multiplied by 505. So I power 4 is 1, and 1 power anything, 505 will also be equal to 1. Okay, I power 1945. Let's take 1945 over 4. It will give us 486 and 1 over 4. Okay, this is a remainder here. 1 over 4 is a remainder. So we can say it's I power 4 plus 1 and I power 4 multiplied by 486 plus 1. Oh, it will give us I. As you remember, I power 4n plus 1 will always give us I. Okay, let's carry on. Have I power 687. Let's see, 687 over 4 will give us 171, and 3 over 4. 3 here is a remainder. So it's I power 4n plus 3. So I power 4 multiply 171 plus 3 will give us negative I. Add this formula here, I power 4n plus 3 will always give us negative I. Okay, I power 10. Let's take 10 over 4 will be 2.5. Don't be tricked here. All of these remainders here are 1 over 4, 3 over 4, as it's divided by 4. But here, the remainder is 1 over 2, not 1 over 4. So it's equivalent to 2 over 4. Okay? Not 1 over 2, the remainder here is 2, not 1. Okay? So it will be I power 4n plus 2, as 4 multiplies 2, 4 times 2 is 8, plus 2 is 10. Okay? This formula will always give us negative 1. Okay, let's see here how to use it by the calculator. We have 6 here, 687 divided 4 equals 687 over 4 with this shift and SD. It will be 171 and 3 over 4. As you see here, the 3 is the remainder. Okay, let's reset. Then 2020 divided 4 give us 505, no remainder here, and 1945 divided 4 it will give us 486, and 1 over 4 the one is the remainder. Okay, then divide 4 give us 5 over 2, which is 2 and 1 over 2. Okay, there is another method. We can use mode and 2. Now we can use the ENG. It will give us the I and give it power 2, 120. It will give us 1. Then we will reset ENG to give us I power 1945, it will give us I. Okay, then reset ENG to give us the I, and X power to give us the power 687 will give us negative I as we show here, and ENG to give us the I power 10 will give us negative 1. Okay, now you've seen how it's done by calculator. Okay, Okay, let's see real numbers. More details. We have 5, -2, even square root 2, pi, any constant number. Okay, plus the imaginary number, such as any imaginary number, I, -3i, 5.4i, root 2i, root 5i, pi I, any constant number multiplied to I is an imaginary number. Okay, we always this is a standard form. The real number is indicated by A, plus the imaginary number coefficient is B, and the imaginary is I. This is the standard form of the complex number. Okay, this is an examples of complex numbers. We have 22 plus 7i, this is in the standard form, and 2 minus 30i, also in the standard form, a plus 3.4i, and so on. Now, adding complex number. Add these two complex numbers. 22, 2.2, I'm sorry, plus 7i, and 2 minus 5.8i. Okay, let's add them together. We will gather the real together, the 2.2 and the 2, and the imaginary together, 7i and -5.8i. Okay, we gathered the real here under the white line here, and the imaginary here above the blue line here. So simply add them. We have 4.2 plus 1.2i. Ex, subtract these two complex numbers, 2 plus 3i and -3 plus 3i. Okay, let's subtract them. We have 2 plus 3i minus -3 minus 3i. We will break the brackets, negative multiply -3 and negative multiply -3i. So we have 2 plus 3i plus 3 plus 3i. Sorry, minus 3i. So these two will cancel out each other, the positive 3i and the negative 3i. So we'll have 2 and 3. Will give us 5. Exercise 2. Solve I cubed plus I power 4 plus I power 5 plus I power 6. I cubed is I power 2 in I, as I power 2 will be -1i. We always know that I power 3 will be -i, and I power 4 is always equal to 1, and I power 5 is always equal to I, and I power 6 is always equal to I power 4, I multiply I power 2, I power 4 plus 2, which will give us -i plus 1 plus I minus 1. So -i will cancel out the I, and the 1 will cancel out the -1. So the final answer will be 0. Okay, add 2 minus 5i and -2. Okay, we have them here. Put the real with the real here. 2 and -2. We cancel out each other because we have positive 2 and -2. So the answer will be -5i. Subtract 22 minus 5i and -2 and -i. Okay, 22 minus 5i minus -2 minus i. We will multiply -2 by -1 and -i by -1. So we will have 22 minus 5i plus 2 plus I. So we will add the real together, 22 and the 2, and the imaginary together, -5i and 1i. So we will have 24 minus 4i. Thanks for watching. See you in the next video. So many of our dreams at first seems impossible, then they seem improbable, and then when we summon the will, they soon will become inevitable. Thanks for listening. Goodbye.